With the SureServo 2's pulse train mode, you can send pulses to the servo drive to control the servo motor's movement. This is most common in CNC type applications. And it couldn't be easier. We just reset the drive to factory default, wire it up, enable the servo motor, and send it some pulses. Let's do it. I'll go to parameter group 2, parameter 8, and set it to a 10 to reset the drive to factory default. And it's always a good idea to power cycle the drive after a factory reset to make sure everything got cleared out. In my little demo station, I have an Automation Direct Bricks PLC sending pulses to the SureServo drive, which controls the servo motor, which is connected to this IGUS linear slide. I wired the PLC to the drive using this 24-volt NPN setup because it's what the default SureServo drive expects. There are diagrams for PMP wiring in the user manual. And you can also use line driver inputs, which gives you up to 4 MHz signaling versus the 200 kHz of the single-ended wiring, and much better noise immunity. So definitely use line driver inputs when you can. Now what if you don't have a 24-volt controller? Maybe you're using a microcontroller with 5-volt outputs. Well, that's one of the cool things about the SureServo 2 system. We wired it like this because the current limiting resistor we need for the 24 volts is built in. That saves us the time and trouble of adding that ourselves. But look at this. The drive brings this signal out so you can add your own current limiting resistor, which means you can use any voltage you want, within reason, of course. You're just powering the LED in an opto-isolator, so to do 5 volts, for example, you would delete this wire and wire this pin through a 220 ohm resistor to the 5-volt rail to create the roughly 15 milliamps the opto-isolator needs to turn the LED on. How about that? The only caution is, whatever you do, don't run a voltage in with no limiting resistor. You'll probably burn out that opto-isolator, making the drive useless for pulse train mode. So please be careful with that. Okay, let's get back on track. I chose the Do More Bricks PLC because it has high-speed I/O built in. I don't need to buy an extra high-speed output module. And it happens to be compatible with the max pulse rate of the SureServo drive. And I happen to have one laying around. You can use any controller you want. We have a bunch of videos showing you how to set up and program the high-speed I/O in a Do More PLC, so I'm not going to spend any time on coding the PLC here. Just know that if I enable this contact, the Bricks PLC will send 100,000 pulses in one direction at a rate of 100,000 pulses per second. And if I enable this contact, it sends the same 100,000 pulses in the other direction. I'll include the PLC's ladder code in the comments below the video if you want to take a look at it. Well, that's it. We reset the drive, wired up a PLC, added a couple rungs of ladder code, and we're ready to go. So I'll enable the servo motor and display the servo motor's encoder count. I'll enable this contact to send 100,000 pulses. That wasn't very impressive. I'll click on this guy to go back 100,000 pulses. Same thing. We sent 100,000 pulses, and that's all we got? What happened? Remember, the SureServo 2 motor has over 16 million pulses per revolution that by default gets scaled by the electronic gearing to 100,000 pulses per revolution. And since the PLC sent 100,000 pulses, the motor turned exactly 1 revolution, which is 5 millimeters or roughly 2/10 of an inch of travel for the carriage, and then it stopped. And since we sent that 100,000 pulses at a rate of 100,000 pulses per second, it took 1 second to do it. So if we want the carriage to travel farther, we could send 10 times the pulses to go 10 times as far. But it'll take 10 seconds to do it. That's way too slow. We could send the pulses faster, but processors are limited in how fast they can send pulses. I could tell this Bricks PLC to go twice as fast, but not much more. And even that would just take us down to 5 seconds for the longer move. That's still too long. So when you run into limitations like this on the controller side, it's time to modify the servo side. And that's where electronic gearing comes in handy. It changes the pulses per revolution of the servo motor. We'll explain exactly how electronic gearing works in a separate video, but for now, just know that in a factory default drive, whatever you put in parameter 1.45 is how many pulses per revolution the motor will react to. Right now, we see the lower half of this number is 0, and the upper half is 1, so that's 100,000 pulses that are required to rotate the motor shaft once. Do we really need 100,000 pulses per revolution? No. If I disable the servo motor and then change that to 10,000 pulses per revolution, then the 100,000 pulses the PLC is sending should make the carriage go 10 times as far. And since the pulse rate hasn't changed, the carriage will get there in the same amount of time, which means it'll be moving 10 times as fast. I'll re-enable the servo motor, bring up the encoder count display, and send the 100,000 pulses. And yep, the carriage moved 10 times as far in the same amount of time. Send 100,000 pulses in the other direction, and the carriage returns just as fast. Perfect. So, it's really important that you balance your processor's output rate versus the resolution of the servo motor. You can get incredible resolution with the servo system, but if you have a slow processor, it'll take forever to make the move. You need to choose a servo motor resolution that's good enough to get your job done, but they'll also work well with your processor. And be sure to use the drive's built-in line driver signaling whenever possible to get the fastest and most reliable control. Now, we used pulse and direction in this video. What if you wanted to use clockwise counterclockwise signaling instead? Easy. Just change the pulse type in parameter 1.0 and change it into PLC, and you're ready to go. And it's the same thing with quadrature pulses. Just change the quadrature option in both places, and you're ready to go. But there are a number of things you can do to improve the performance of your system. You can enable speed and torque limits to protect your system. You can monitor the encoder pulse rate as a voltage on an analog output pin. You can set up multiple torque limits, so depending on the application, you can quickly switch how much torque the motor can generate. You can have multiple electronic gear ratios that can be applied to the motor without having to reconfigure the drive. You can modify the encoder pulse outputs from the drive. You can limit the max speed of the drive, and you can modify the acceleration and deceleration times. Meanwhile, click here to learn more about the SureServo 2 system, including where to find more videos. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.